In this video, I'll be solving the third problem of UPSC Civil Services Mains Statistics Optional Paper 1 2024. So we are asked to find the maximum likelihood estimates of alpha and beta for a random sample from the exponential population. Now we can clearly see it's a location exponential family or location exponential distribution. So if we normalize, we'll be getting like C value. So first thing is, like, we were given the density f of x alpha beta, which is c e to the power minus beta into x minus alpha, and x is greater than or equal to alpha and beta is greater than 0. So integration c into e to the power minus beta x minus alpha dx from this alpha to infinity, so that is nothing but c times integral 0 to infinity e to the power minus beta u du, where this x minus alpha, I'm considering it as some u. So that means this is nothing but c by beta, and this should be 1. So that implies c is nothing but beta. So therefore f of x alpha beta, so that's nothing but beta into e to the power minus beta x minus alpha, where x goes from alpha to infinity and beta is greater than 0. So now for a random sample, so if we consider like for a random sample, like some x1, x2 and so on xn, so likelihood is the product of all these densities, so beta into e to the power minus beta xi minus alpha, that's nothing but beta to the power of n into exponent of minus beta summation I is equals to 1 to n xi minus alpha. So now the parametric space is constrained by alpha less than or equal to minimum of this sample. So that's nothing but the first order statistic. Otherwise the likelihood is 0. So therefore if I consider some s is equals to summation I is equals to 1 to n xi, so I can write the likelihood as beta to the power of n exponent of or e to the power minus beta into s minus n alpha, where this alpha is less than or equal to the first order statistic. So now, like, if we find the maximum with respect to alpha, if we maximize with respect to alpha, now for fixed beta greater than 0, this e to the power beta and alpha, so like by seeing this, like it shows like L is increasing on that range. So therefore this likelihood is maximized at the largest possible value of alpha. So therefore, like, alpha hat MLE is nothing but the sample minimum, because the likelihood is maximized at the largest possible value of alpha. So basically the maximum likelihood estimator of this alpha is the sample minimum. So this is like maximization with respect to alpha. Now if we maximize with respect to beta, so if I take the log likelihood after substituting alpha is x of 1, so that is first order statistic, so that is n ln beta minus beta into s minus n x of 1. So this is the log likelihood of this particular function. So if I differentiate with respect to beta and set it to 0, so dou L by dou beta is n by beta minus s minus n x of 1. So this is 0. So that means this beta hat MLE is nothing but n by s minus n into first order statistic. So that's nothing but n by summation I is equals to 1 to n times we are having the first order statistic, so xi minus x1. So that will be the beta hat MLE. So therefore alpha, so the maximum likelihood estimator of this alpha is x of 1, the first order statistic, and beta would be n by summation of xi minus x of 1. So therefore so both the estimates, they're like invariant and they're like standard for this location exponential distribution. So that's it for this video. We'll meet in the next video.